So welcome everybody. This is the graphs of sine and cosine part 2. And in part 2, we're gonna be doing all the transformations. Okay, all possible transformations that one can give you. We're gonna be covering today. So before we do that and before we get into that, kind of want to quickly just cover what sine and cosine, the parent function is. So I have an XY graph here. My X coordinate or my X axis is in radians. Okay, so it's going to be in radian 4, right? All the radians. And my Y axis is just whatever we're graphing. If we're graphing sine, it's just that function. Okay, so the value of that function. So if this is y equals sine of x, remember that everything is based on this unit circle here, right? So 0, pi over 2, pi, and 3 pi over 2, and then 2 pi is one full rotation. So what I'm going to do here, just to make it neat, is go every 2 units. This is 0. The origin is 0. Every 2 units is going to be pi over 2. Okay, so pi over 2, pi, 3 pi over 2, and then 2 pi. If I go the other direction, this is going to be negative pi over 2. This is going to be pi. This is going to be 3 pi over 2 negative. And this is going to be negative 2 pi, right? So we are going to be graphing this in your final graphs over 2 periods. Okay, so that means there's 2 rotations around the unit circle. Okay, so I want to label this 1 and label this as negative 1. So the sine of 0 is 0. Sine of pi over 2, if you guys think back to your unit circle, it's the y value, is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is 0, right? And if I graph sine of negative pi over 2, remember, class, if it's negative pi over 2 in the unit circle, that means that in standard form, right, you're going to start off with the positive x-axis, and you're going to move down pi over 2, right? Go clockwise pi over 2, which is the same thing as 3 pi over 2, okay? So the value for sine of 3 pi over 2 is the same thing as the value of pi over 2, which is negative 1, okay? The value of sine of negative pi is the same thing as the sine of pi, which is 0. Negative 3 pi over 2, sine of negative 3 pi over 2 is the same thing as sine of 2 or pi over 2, positive pi over 2, which is 1. And then negative 2 pi is the same thing as 2 pi, which is 0. So I have these coordinates here. I'm going to try my best to make the nicest sine curve I can. Okay? So that is, right here is 2 periods, right? 1 period is here. 1 sine wave is here. Okay, so over 2 periods, what's going on? And we can do this for cosine as well. Okay. For cosine, now I'm going to do this a little bit quicker than sine. Okay. So every 2 units, it's going to be pi over 2. pi, 3 pi over 2, and then 2 pi. And then here, negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi, right? And then for cosine, it's still at 1 and negative 1, okay? Based off of the unit circle again, cosine of 0 is 1, cosine of pi is 0, cosine of, or pi over 2 is 0, cosine of pi is negative 1, 3 pi over 2 is 0, cosine of 2 pi is at 1. Negative pi over 2, just try and make this V shape, but when you draw it, try and make it as smooth as possible, okay? All right, so that's my cosine graph right there over 2 periods, okay? 1 period here, 1 cosine wave here. Cosine wave, cosine wave. Yeah, cool. So here, remember, my amplitude is here, okay? And that's what we covered in part 1. So in this part 2, what we are going to do is something like this, okay? 3 sine of x minus pi plus 1. Okay, this isn't all the transformations, but it's the majority of it. So here, before I jump in and dive into graphing, what I'm going to do here, y equals 3 sine of x minus pi plus 1, right, is I am going to label all the transformations. All right. So this is my amplitude, which will be a vertical stretch by a factor of 3. Okay, BAFO by a factor of 3. This one here is going to be a vertical shift up 1 unit. And this minus pi here is going to be going to the left pi units. Okay. Yeah, and that's why in here, you're going to see a majority of the time it's going to be in terms of pi. Okay. If it's not, then we can deal with it then. All right. Okay. So over 2 periods again. So going every 2, we're going to make it pi over 2. Pi, 3 pi over 2, and 2 pi. Here again with the negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And I'm going to start off here. I'm going to go 1 and negative 1. That's 2. That's 3. That's negative 2. And that's negative 3. Notice that I've already labeled here, right? At negative 3, because I know I'm going to vertically stretch this by a factor of 3. I'm going to move it up 1, so I'm going to go with 4. Okay? Here, I'm going to move it over pi units. So I know I'm going to have this guy go over pi units. So this is going to be 3 pi. In between 2 pi and 3 pi, it's going to be 5 pi over 2, right? So that's your first step, class, okay? Just getting your transformations, right? Kind of thinking it through, visualizing what the transformations do, and labeling your graph as such. Okay? You guys don't have to go to that extra step of labeling. You guys can label after. But if you guys can label before, that'd be awesome. Okay? So I'm going to graph the parent function first. So 0, 0, it's sine. So pi over 2 is 1, 0, -1, 0. And this one is -1, 0, 1, and 0. Right, that's my parent function there. Okay. And we always want to stretch this out before we shift it. Okay. Always do the stretching before we stretch or before we shift. Okay. So the vertical stretch by a factor of 3, that just means, class, that the ones and the negative ones go to 3s and -3. Go to 3 and -3. And all my zeros stay the same. Okay? So here in green, it's gonna look like this. Okay? And you guys see how it stretched out, right? So in this color here, I'm gonna make a key. Y equals 3 sine of x. In this color here, it's y equals sine of x. Okay? Cool. And then literally, we're just gonna move this over, pi units over to the right, and shift it up 1. So get every point, right? We're gonna get every point, get this point here, shift this point over to the right pi units, which is actually 4 boxes. You guys want to think about it like that, and shift it over 1. That's my new point there. Okay. Oops. All right. Get all the zeros first. I would say that's pi units of up 1. This one here, that's pi units up 1. That's pi units up 1. That's pi units up 1. Okay. And then once you get your zeros, class, you know your amplitude is 3, right? You could do this one of 2 ways. You could do this, go pi units, that's 4 boxes, 1, 2, 3, 4, and then up 1, which is right there, right? 1, 2, 3, 4, and then up 1, which is right there. Here, or what you can do is it's gonna go up 3, it's gonna go down 3, right? So in between these 2 zeros, it's gonna be pi over 2, and it's gonna be up 1, which is at -2 instead of -3, right? So I literally did 1, 2, 3, 4, up 1. Yeah. 1, 2, 3, 4, up 1. So you guys see all of those points. And if I connect these points here, it's gonna look something like this. Okay. So in red, it's gonna be y equals 3 sine of x minus pi plus 1. And that's my final graph. All right. Questions? Pretty simple. Yeah. Okay, let's do some more. Or are you guys still? My next one here is y equals -2 cosine of x plus pi over 2 plus 2. Okay, and there's a bunch of 2's. So this, I should just put the negative as a separate transformation, but I'm not. It's going to be a reflection over the x-axis. That's what the negative does. And a vertical stretch by a factor of 2. Okay? And then here, it's going to be a shift to the left, pi over 2 units. And here, it's going to go up 2 units. Okay? All right. So if you look at, you look at that, going to be a vertical stretch by a factor of 2, and it's going to go up 2 units, right? So when I'm labeling this, I'm going to label this each unit as 1. Okay, 1, 2, 3. I'm going to go to 4. Okay, I'm going to go here, 1, or -1, -3, and -5. Okay, just to label it a little bit. Every 2 boxes, I'm gonna go pi over 2. I do every 2 boxes, right? Every 2 units is pi over 2 because it just, or not 2 pi, just pi. Because just keeps it neat. All right. This would be negative pi over 2. This is negative pi. This is -3 pi over 2. This is -2 pi. Right? And I know I'm going to go to the left, pi over 2. So I'm just going to go another one. That's -5 pi over 2, right? Okay. So my parent function here of cosine is going to be 0, 1, pi over 2, 0, pi is at 1, 3 pi over 2 is at 0, 2 pi is at 1, and then just continuing that trend. Oops, it's right there. Okay, so it's going to look like this. And it does look thinner because my y value is more scrunched in. Yeah, it's more compact. So that's my cosine value, and this is just a mistake. Okay, so just erase that. Here is y equals cosine of x. Okay. And in blue, I'm going to do these 2 transformations simultaneously. I'm going to reflect it over the x-axis and then vertically stretch it by a factor of 2. Okay. Now looking at these zeros, the x-axis, all of these 4 zeros, 1, 2, 3, 4. If I vertically or if I reflect it over the x-axis, it stays the same, correct? If I vertically stretch it by a factor of 2, it stays the same, correct? So these zeros here, my y value is 0, stays the same. The only thing that changes is the ones and the negative ones. All right. So if you have a point at 1, it's going to reflect it over the x-axis, which is at -1. And it's going to be a vertical stretch by a factor of 2. So it's going to be at -2. So all the ones become -2. Questions on that? So I have this 1 becoming -2, this 1 becoming -2, and this 1 becoming -2, right? Vice versa for the ones here or the negative ones here. -1 reflected over the x-axis, it becomes +1, vertically stretched by a factor of 2, becomes +2. Yeah? So this point becomes here, this point becomes here. So here is my new cosine wave. Yeah. And you guys see that it stretched out. Yeah. It doubled in size and it reflected. So this in blue is y equals -2 cosine of x. Okay. And all I'm going to do here is just move everything over to the left, pi over 2, and then up 2 units. Okay. Now, I always start off with the zeros because the zeros have 4 points, right? So here, I'm going to go pi over 2, which is just 2 boxes over, up 2. Pi over 2, up 2. Pi over 2, up 2. Pi over 2, up 2. Right? So those are my 4 zeros right there. Now in between, or on the left-hand side, pi over 2, up 2. It's going to be at 0. This point, pi over 2, up 2. It's going to be at 4. -3 pi over 2 and 4. This point here, pi over 2, up 2. This point here, pi over 2, up 2. And then this point here, pi over 2, up 2. So here is my new graph. Okay. My amplitude here, class, is still +2. Okay. So that, or this point in green is y equals -2 cosine of x plus pi over 2 plus 2. And I did it over 2 periods. Okay. So this line here, all right, my x-axis, right, it shifted up 2 units, correct? So this, if you guys remember, we talked about it a little bit in part 1, this would just be my sea level, my new sea level. All right, my amplitude does not change from that, from the blue, okay? So that's why my amplitude is still at 2. Because this size here is 2. Okay? Green is the final product. It's the whole equation. All right? Sounds good? Questions on that? Now, this one, this next transformation, I kind of put it to, or by itself, because it's the most difficult one to kind of wrap your head around. Okay? So remember this b value, right? Y equals sine of 2x. What is the b value? What does that affect? Or if you guys want to put it in terms of transformations, what type of transformation is that? Horizontal. It's a horizontal stretch or compress, okay? Given the value that's in here, okay? Here in terms of trig functions, that would affect my period. Remember my period formula is 2 pi over b, right? My b value here equals 2, okay? So my period would be 2 pi over 2 or just pi. All right? This is where it gets a little funky, okay? I am worried. Okay, so you know how my x values in radians, right? Go from 0, pi over 2, pi, 3 pi over 2, and then 2 pi, right? It does that, right? It has 5 points, right? 0, pi over 2, pi, 3 pi over 2, and 2 pi. But my period shrunk to pi, right? So here, this will still be at 0. I'm going to divide everything here by what? By 2. Does that make sense? So if I divide pi over 2 by 2, I get pi over 4. Pi by 2, I get pi over 2. 3 pi over 2 by 2, I get 3 pi over 4. And then 2 pi divided by 2, it will just be pi. So now my period is correct, right? And these are my new x coordinates. That make sense? Yeah. Okay, so that's 0. You can still go 2 units and go pi over 4. But honestly, I'll just go every box. Okay, and that's pi, right? That should be pi. Okay, so if that's pi, I'm gonna go 3 pi over 2 and then 2 pi, right? I'm gonna graph my parent function first. I want to make this a 1 and this a -1. So 0, 0, pi over 2 is at 1, pi is at 0, 3 pi over 2 is at -1, and then 2 pi is at 0. So here is my parent function, right? But this wave now kind of shrunk in to these red points, right? The points up here. Okay? So this point moved to here. This point moved to here. This point moved to here. And this point moved to here. There's my one period of this, right? And honestly, class, if you have to run it over 2 periods, I know that we did the negatives, but we could just add another one here, right? Up 1 to 0, down 1 to -1, and back to 0. So you guys see how 2 periods equals 1 period of the pi, or of the family, not family, parent function, because we cut our period in half. Okay? You guys see that connection? Yeah. Cool. Let's try this one. Cosine of 4x. So what are we doing to our period? 2 pi over 4, right? 2 pi over b, which is pi over 2, okay? My zeros, or my x-axis, axis, still with the pi over 2, pi, 3 pi over 2, and 2 pi, now shrinks. What am I going to divide this by? I'm going to divide it by 4, right? Since I divided my period by 4, I'm going to divide my y-axis by 4, okay? So divide this by 4, 0 divided by 4 is still 0. Pi over 2 divided by 4 is pi over 8. Pi divided by 4 is pi over 4. 3 pi over 2 divided by 4 is 3 pi over 8. And then 2 pi divided by 4, that would be pi over 2. Okay? So you know how before I left my units as is, right? In this case, I am going to make every unit each of these guys. Okay, so 0, pi over 8, pi over 4, 3 pi over 8, and then pi over 2, right? If that's pi over 2, 1, 2, 3, 4, 1, 2, 3, 4, that would be pi. 1, 2, 3, 4, that would be 3 pi over 2. 1, 2, 3, 4, this would be 2 pi. You guys see how it would look better if I just lengthen or widen my cosine graph, right? Rather than shrinking the transformed one. Okay. So my parent function here, I'm going to leave this as 1 and leave this as -1. 0, it's cosine, so it's 1. Pi over 2 is at 0. Pi would be at -1. 3 pi over 2 is at 0. 2 pi is at 1. So here is my, graph. Okay? That's my parent function. Y equals cosine of x. All right? And this guy shrinks down to the fitting here. Okay, so it literally shrinks it. So 0 is still at 1. Pi over 8 now is at 0. This pi and -1 becomes pi over 4 -1. This 0 becomes 3 pi over 8. And this 2 pi becomes pi over 2. So here is my graph. Okay? All right. So when someone grades this, right? When I grade it, I am going to look at your graphs essentially are going to all look the same, right? The only difference when we're doing horizontal is, did you label this correctly? Okay. Are the units correct? Okay. So here is 1 period, right? If I needed to do 2 periods, I know that every unit, I'm just going to go like that. Okay. And you can do it again. I kind of want to show you guys this. Okay, that's 3 periods. And this will be 4 periods. Right? Notice that 4 sine curves or 4 cosine curves, 1, 2, 3, 4 is in one of the regular parent function curve. Okay? Because we cut our period by 4. Yeah? Cool? Make sense? Okay. Okay, so for this one here, we are doing all the transformations. This is the most complicated one that I could give you. Okay. The first thing we got to do though is do a little bit of algebra. Okay. Because in our general form, our B is on the outside. Okay, so you guys can think about it like this. Okay, 2 times, if I factor out a 2, what happens to this pi over 2? If I take out a pi over, or if I take out a 2, what would this become? If I take out a 2 like I did here, right? It'll be pi, no, but pi times 2 would be 2 pi, not pi over 2. Pi over 4. Okay? Minus 2. And now we're just going to do the same thing that we did. Okay? Keeping in mind what we just did with our B value. Okay? So here, this 3 is a vertical stretch by a factor of 3. That means my A value is 3. Okay. This pi over 4 and this 2, this negative 2, this pi over 4 went to the, left, pi over 4 units. And this negative 2, it goes up 2 units. Right? Up. Or minus, so it's down. Which one? No. You got to think opposite on the inside. So since it's a plus, you go to the left. And since it's a minus, you go down. Down 2 units. Okay? And this 2 here, class, I'm going to get my period. My period is 2 pi over B. My B value is 2. So my period is going to be pi units. Okay? So again, if my period changed, then 0, pi over 2, pi, 3 pi over 2, and 2 pi. This value changed as well, right? All of my x coordinates. Since I divided my period by 2, I'm going to divide this whole thing by 2. So my new x values are going to be at 0. Pi over 2 divided by 2, that's pi over 4. Pi divided by 2 is pi over 2. 3 pi over 2 divided by 2, that's 3 pi over 4. 2 pi divided by 2, that's 2, that's just pi. Right? And class, just to check your work, this number here, right? This value here should always match your period. Okay? That's just to check your work, right? Because my period was 2 pi. From 0 to 2 pi, that's a distance of 2 pi. Now from 0 to pi, that's the distance of pi. Okay? Yes. Why do I need to factor it from the start? Because this 2 here in general form, it just has the x. So when you have a coefficient with the x, you would have to factor it out because that affects my shifting, okay? It affects this value, all right? So here is my new x values. So I'm gonna go 0. Actually, that works out. I'm gonna keep it as is, pi over 2, pi, go 2 units, 3 pi over 2, go 2 units, 2 pi, okay? Now just every box is gonna be pi over 4, right? Or every, yeah, 1 unit. I'm gonna go down to make this a 1, make this a -1. Since I'm gonna go down 2, we're gonna label all the way to -3. -4, -5, and -6. Okay, all the way down to -6. Because I'm gonna vertically stretch it by a factor of 3 as well. Okay? 2 and 3. All right. So here we go. My parent function, I'm not going to use that color. 0, 0, pi over 2 is at 1. It's a cosine. 0, 1, pi over 2 is at 0. Pi is at -1. 3 pi over 2 is at 0. And 2 pi is at 1. So that's my parent function right there. Right? From here, I'm going to vertically stretch it by a factor of 3, meaning the 1s become 3s, -1 becomes -3. Zeros stay the same, the 1 becomes 3, right? Okay. Now I'm going to do the horizontal, changing my period up. So 0, 3 is still the same. This point becomes pi over 4. This point becomes pi over 2. This point becomes 3 pi over 4. This point, oh no, this point becomes at 0, huh? And then 2 pi becomes pi. Oh, there. So it's like that, right? Okay. All right. And if I had to do this over again, one box, go over 2 periods, one box, go down to -3, one box, go up, back up to 0, 2 pi is going to be up there. Okay. And then from here, we're going to move this over to the left, pi over 4 and down 2 units. So here, pi over 4 down 2 units. 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 Okay. And here is 1 period of my function. You guys see that? So that becomes here, going another period, basically just copying down the points. Here's another period. Okay? And yes, I will be grading this like this. You guys just think about like this. What is going on, right? But I can see it if you guys graph it like this. Okay? Let's do one more. Yeah. Let's do one more. I don't get one. So y equals negative sine of, gotta factor out the 4, x minus pi over 4 then, minus 2, right? So doing this really quickly, this negative here is a reflection over x axis. Doing these guys here and here, down 2 units again. Here to the right, pi over 4. And then this 4 affects my period, which is 2 pi over 4 now, which would be pi over 2, right? Maybe doing this first would help resonate with you guys. Hold on. So we have that as our x coordinates, right? Yeah, our parent x coordinates. Divide everything by 4 because that's what I did to the period. 0, this would be pi over 8, pi over 4, 3 pi over 8, and then pi over 4, right? Or pi over 2, I'm sorry. Okay? You know what? I won't require the parent function every time. Okay? Because this is a sine function. So this is 0. I'm going to go every 1 going to be pi over 8. So that's 2 pi over 8, so pi over 4. This is 3 pi over 8. And this will be pi over 2, right? By now, you guys should be kind of understanding the key points, right? If that's 1 and that's negative 1. Here, the sine function, 0, 0. Pi over 8 will be at 1. Pi over 4 will be at 0. 3 pi over 8 will be at negative 1. And pi over 2 will be at 0. So this here, class, is y equals sine of 4x. That's what I just graphed. Make sense? If you get into that rhythm of 0, next point is 1, next point is 0, next point is negative 1, next point is at 0, now you just graph that. Okay? And the hard part is done. Because that was the hard part. Right? And I'm going to reflect this over the x-axis. So my zeros stay the same. This 1 becomes a negative 1. This negative 1 becomes a positive 1. So it looks like that. Right? And I'm just going to move this over pi over 4 units to the right and down 2 units. So pi over 4 units would be here, would be 2 boxes, right? So I'm going to go pi over 2. This is 5 pi over 4 or 8. And this would be 6 pi over 8 or 3 pi over, or 3 pi over 4, right? Okay. So every, let me use this. Every point, I'm going to move over pi over 4 down to 1, 2, right? Pi over 4 down 2, 1, 2. Pi over 4 down 2. This one is in between these two first zeros, 1, 2. And this one is in between these two zeros. So it becomes like that. So that is my function. And then over 2 periods from here, right? You kind of got a rhythm, right? Just to move it over, right? Just go my next point down 2, next point up 2, next point up 2, next point down 2. And there's my 2 periods. That makes sense? Yeah. That's the lesson for today. Hopefully this made sense. See you on the next one.